In this video, we are going to discuss about design of 2-bit synchronous counter using JK flip-flop. So you can design with the help of any flip-flop. Here I am going to take a synchronous counter. So since it is a 2-bit, you have 4 states, right? That is nothing but 0, 0. The 4 states, right? Since it is 2-bit, here this is 2-bit. So you have 4 states. Okay. So I'm going to design a up counter, right? So up counter means it will count from 0, then it goes to 0, 1, then it goes to 1, 0, sorry, then it goes to 1, 0, after that 1, 1. Then the cycle get repeated. So after 1, 1, it goes again to 0, 0. So this represents nothing but your state diagram. Next, let me draw state table based on this. So here you have 2 bits, right? So you require 2 JK flip-flops, and since I have 2 JK flip-flops, I have QA and QB. That I name it as QA, QB as my present state. Okay. So if the present state QA and QB is 0, 0, the present state QA, QB is 0, 0. What will be the next state? Next state is 0, 1. So the next state QA plus. So you can, this is a notation, okay? This plus percent next state, it goes to 0, 1, right? So if the present state is 0, 1, the present state is 0, 1. If the present state is 0, 1, what will be the next state? It is 1, 0. So if the present state is 1, 0, what is the next state? 1, 1. If the present state is 1, 1, it goes to 0, 0. Again the cycle repeats. If the present state is 0, 0, so I'm going to stop it here. And I'm going to use JK flip-flop. I already told you I'm going to use 2 JK flip-flop, right? Since I have 2 bits, okay? So you know the table for the excitation table for, I have to write the excitation table for JK flip-flop. So this is for Q1, Q plus JK. The excitation table is for the input is Q and Q part, Q plus. So you will get you can write the J and K value. So if I write the J like this, K is I have to write it in the inverse. So if I mention this is QA plus, this is JA K. So for 0, 0, for 0, 0, JAK is 0x. For 0, 0, for 0, 0, for 0, 0, JAK is 0x. For 0, 1, for 0, 1, it is 1x. For 1, 1, for 1, 1, it is x0. For 1, 0, it is x1. Similarly, for B, okay, for B, for 0, 1, it is 1x. For 1, 0, it is x1. For 0, 1, it is 1x. For 1, 0, it is x1. So next I need to form the K-map. K-map for J. So what are the my present state QA and QB. So I'm going to use two variable K-map. Zero, 1, 0. If QA and QB is 0, 0, what is my JA? JA is 0. If QA and QB is 0, 1, 0, 1, JA is 1. So next is XX. So if I group this one, I'll get QB. Similarly for I'm going to write the K-map for K. So this is my J, okay. K-map for K, 0, 1, 0. This is QA and QB. So I'm just substituting the value XX 0, 1. XX 0, 1. So this is nothing but QB. So K is equal to QB. So similarly, you can see this is these are all 1. So I can write JB is equal to 1 and KB is also equal to 1. So if you want to elaborate K-map for KB. So I already told you the answer. Okay. This one. So outright X1, X1. X1, X1. So I can group the entire term. I can consider this X as 1. So the answer is 1. So my KB is equal to 1. So now I'm going to draw the diagram for so this is my logical diagram or logic diagram. So this is for I have two flip-flops. I have used the two flip-flop J, K, Q, Q bar. This is my B flip-flop and this is my A flip-flop. Which means this is JA and this is QA, this is KA, QA bar. Okay. Since it is synchronous circuit, I am going to use a clock comma. So what is JB and KB? JB and KB is 1. Okay. What is JA? JA is nothing but QB and JB also QB. So I'm going to connect it like this. This is QB, right? This is QB. So I'm going to connect it like this. This is a design of a JK flip-flop. So next I'm going to implement this one and using a digital train kit. So for that one I'm going to implement this on digital trainer kit, right? So therefore I want to know so I'm going to take the JK flip-flop. So the IC name is IC 7476. It is a 16 pin IC. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is your first pin. So you have a dot here. So this represents your clock of the first JK flip-flop. So inside this IC you have two JK flip-flops. Okay. So this is a clock of the first JK flip-flop. Each one is reset bar. So it is active low pin. So if I want to make this one reset to therefore if I want to make the first JK flip-flop reset, it has to be 0. Okay. Next serial. This is reset. The third pin is reset. And the fourth pin is J1. And the fifth pin is VCC. Sixth pin is second clock of the second flip-flop. This is a set of the second flip-flop. And this is a reset of the second flip-flop. These are the active low pins. So first clock of J. This is output 1 Q bar. Q1 Q bar is output, right? So 13th pin is ground. 12th pin is 2K. The 11th pin is 2Q. 10th pin is 2Q bar. 9th pin is 2J. Okay. So now let us see how it is going to implement in JK flip-flop and how I am going to get the output. Let us now discuss how to connect these two flip-flop using a digital trainer kit. First, I have connected the supply pin. So supply pin to the fifth pin and ground is nothing but your 13th pin. So here, though the IC consists of 2 JK flip-flop, I selected, I am using 2 ICs and I have chosen second JK flip-flop. Okay. So first, the first pin of the input is connected to the 9th pin, which is represent J. Okay, and the 12th pin is connected, 12th pin represent K. So in the picture, it represent JB and KB. The 6th pin is clock. And 7th pin is your set and 8th pin is your reset. So it is active low pin. So if you are keeping it low, it represent it is clear and preset. So I am going to make it as 1-1. Okay. Similarly, I am going to connect it for the second IC. Okay, the 7th and the 8th now. Now I am going to connect 11th pin. 11th pin is your output. So it is nothing but QB in the picture. And this QB must be connected to the input of the second flip-flop, which is nothing but your 9. And the 9th pin and 12th pin is shorted, right? And then you have to connect the clock. The clock is the 6th pin. And I'm going to connect a preset and set and reset. Pin, the output is taken from the 11th. So if you see the left side is your LSP and right side is your right side IC is your MSP. So that is why I'm not getting the proper output. So if you change it to like this, you will get the proper output. So if you press the clock, it will goes from 0, 1, 2, and 3.